Hello, the learning objective for this video is to be able to factor difference of squares. So far we've factored greatest common factors and we've factored quadratic trinomials like this one right here. Just to remind ourselves, this would factor into the product of two binomials. G and G would be in front to give us a G squared. And the numbers that multiply to 20 that add to 9 would be plus 5 and plus 4. And if you check that, it'll be right. But let's look at something that's slightly different. Take a look at this. Can you figure out how to factor this? Give it a shot, pause the video, and see if you can figure it out. In a second, I'll give you a hint to help some of you guys, and then after that, I'll show you what's going on. Okay, so the first two things you might notice here is that there is no GCF. So we can't pull out a greatest common factor. It's also not a quadratic trinomial. So we can't do what we did here in exactly the same way, unless you think about something, unless you think about the following. I'm going to make it a quadratic trinomial. I'm going to turn this into b squared plus 0b minus 9. Those are the same expressions. I've just added 0b's to it. Now that it's in this form, do you know how to factor it? Try it out. Okay, so I'm going to list the factor pairs for negative 9 and see which ones add to b. Oh, b is 0, so 3 and negative 3 is going to work for us. So that's what I'm going to try. b plus 3 times b minus 3. Let's see if that gives us 0 b's in the middle. b times b is b squared. b times minus 3 is minus 3b plus 3b minus 9. And because we're multiplying b by the negative 3 and b by the positive 3, those are actually going to cancel each other out, and you're left with b squared minus 9. So in fact, the correct factoring for this is b plus 3 times b minus 3. These are called difference of squares. Whenever you have a perfect square minus a perfect square, so it's a binomial whose two terms are both perfect squares and they're being subtracted, those are perfect squares and they have a special form. So there's some perfect squares we can think of. First of all, numbers like 4 is a perfect square, 9 is a perfect square, 16, 25, and so forth. Also, variable expressions can be perfect squares. X squared is a perfect square, y squared is a perfect square, d to the 4th is a perfect square, g to the 6th is a perfect square. G to the 6th is a perfect square because g to the 3rd times g to the 3rd equals g to the 6th, right? Or even more complicated things like 100 y squared. That's also a perfect square because 10y times 10y equals 100y squared. So if you identify an expression that is a difference of squares, take a look at this one. It has a special factoring pattern. Factor this. Pause the video and factor it real quick. Okay, the factoring pattern for difference of squares, once you've identified that it's a perfect square minus a perfect square, the factoring pattern for that is always going to be the same. It's going to be k and k in front. It's going to have a plus and a minus. The plus and the minus, the add and the subtract, allow the linear terms to be obliterated, to cancel each other. And then plus 10 minus 10. And let's see if that works. K squared minus 10k plus 10k. So we have opposites right there. Those are opposites minus 100, which is k squared minus 100. Check. So that's our answer. Try it again. Factor that. Okay, so now the numbers in front, we're in ascending order now. Ascending order? Ascending order? I don't know how to pronounce that. Whatever. What's going to go in front? Well, it's going to be the 7. Don't be bothered that the number's in front. The number can be in front. Leave the 7 in front with a plus and a minus and an x in back. And if we multiply this out, we get 49 plus 7x minus 7x minus x squared, which will again give us 49 minus x squared. Try it again. So is this a difference of squares? No, this is the sum of two squares. This is prime. You cannot factor this. A lot of students see p squared plus 81 and they think it's a difference of squares and they try to factor it this way. P plus 9 times p minus 9. But when you multiply that out, you'll get p squared minus 81, which is not what we started with. So don't be confused by things that are masquerading as difference of squares. How about this one? Can you factor this? Pause the video. All right, 16y squared is a perfect square because 4y times 4y will give us 16y squared. And 5 and 5 will give us 25, and we just need a plus and a minus to make it work. And if you check that, you will indeed be right. Again, all right, here, 11b times 11b will give us 121b squared, plus 3c minus 3c will give us the minus 9c squared at the end. Cool? One more. All right, this one's a little bit more challenging, but not too bad. To get 4b to the 6th, it would be 2b to the 3rd. And to get 49c to the 4th would be 7c squared with a plus and a minus. And we're done. So that's difference of squares. They're actually pretty easy. The important thing is to be able to identify them. So whenever you see something that is a perfect square minus a perfect square, it's a difference of squares. It can be factored just like we did today.